Okay, we're going to look at the reaction between acids and carbonates here. So just to remind us, so this is the carbonate ion. It's got a formula of CO3, and it's got a double negative charge on it. And there's the electronic structure. It's quite easy to understand. So we've got a double bond from carbon to one oxygen, and two singles to the others. And those ones have got an extra electron, which I've drawn in red there. That doesn't belong to them. So you can see the carbon there has got 4 crosses of its own electrons, 1, 2, 3, 4. Each oxygen has got 6 dots, because it's in group 6. Each element thinks it's got a full outer shell, and they've got the 2 extra electrons there, giving it the 2 minus charge. Okay, so just a bit of background there. Now, so the formula of copper carbonate is going to be CuCO3, right, and that's because copper is a 2+ ion, carbonate is a 2-, so copper carbonate, it's an ionic solid. Now, most carbonates, all metal carbonates except for group 1, are insoluble. Okay, they're insoluble solids. As usual, the group 1 carbonates, they are unusual because they are soluble. So sodium carbonate will dissolve. Sodium carbonate is Na2, of course, because the sodium ion only got a 1+ charge in it. Okay, so let's have a look at the equation for the reaction of copper carbonate and sulfuric acid. So we get copper carbonate, which is that green powder there. Put it into some sulfuric acid, dilute sulfuric acid, and it starts fizzing because there's the bubbles there, because you're making carbon dioxide. And the solution turns blue because you have got copper sulfate solution forming there. So that's what we see. Okay, now just to show you how similar that is to, let's get rid of that, okay, to the reaction of metal oxides. So we just get this here. Okay, so here's the reaction of the metal oxide, right? So copper oxide, sulfuric acid gives you copper sulfate, and it gives you H2O. The only thing you don't get is the CO2. And if you look at the carbonate, well, you can see the carbonate ion, you've got 1 carbon and 3 oxygens. Well, 1 carbon and 2 oxygens end up in the CO2. The other oxygen from the carbonate goes into the water. The hydrogens from in the water, they come from the H+ ions in the sulfuric acid. Okay, and essentially the sulfate ions are spectator ions. They don't actually change at all. Right, so if we had to summarize that, you'd say metal, so here you've got metal carbonate plus an acid gives you a salt, and we'll talk about what a salt is again in case you've forgotten, and you get CO2 and water. Now the salt in this case is copper sulfate. But just to remind you what a salt is, right, here we go. Right, so a salt, you can think of it as being what you get when you replace the metal ion in an acid. Sorry, you replace H+ in an acid with metal ions. So the name of the salts that sulfuric acid forms are the sulfates. An example of that would be copper sulfate or sodium sulfate. So you replace the hydrogen with copper in this one and sodium in the second one. Of course, the formula of sodium sulfate is that because sodium is a 1+ ion and sulfate is a 2-, so you need 2 sulfates there. 2 sodium, sorry. Example of the chlorides would be copper chloride or sodium chloride. Yeah. And the nitrates would be copper nitrates, the NO3. That's got a single charge in the NO3 ion, nitrate ion, so you need 2 of them for the copper, which is 2+, or sodium nitrate, which is NaNO3. So metal carbonate plus acid, you get a salt and carbon dioxide and water. So let's just do a few more examples. So let's think, what would we get if we did zinc carbonate, okay? So zinc carbonate, and let's say we react that with hydrochloric acid. Well, that's insoluble. You're going to get the salt, which will be zinc chloride, and it'll be Cl2 because zinc is the 2+ ion, of course, and chloride has got a single minus charge on it. Okay, and then we're going to get CO2 and H2O. That'll be an aqueous solution, gas, and liquid. Right, what do we need to do to balance that? We just need to put a 2 in front of there, and that will do it. Right, let's do sodium carbonate, shall we? Sodium carbonate, which is soluble, but let's say we add it as a solid. And we have that to nitric acid. Right, the salt we're going to get this time is going to be sodium nitrate. And we're going to get CO2 and water. Nitrate ion is 1 minus, sodium is 1 plus. So you can see we've got 2 sodiums there, so we're going to put a 2 there, which means we're going to need 2 nitric acids, which is good because we need 2 hydrogens for the H2O there. So that's balanced. I'll just do one more. Let's do potassium carbonate, which is potassium is group 1, so it's a +1 ion. It's going to be K2CO3. That will also be soluble. Let's react that this time with sulfuric acid. Right, we're going to get potassium sulfate, which is K2SO4 because potassium is 1+, but the sulfate is 2-, so you need 2 potassiums for that. CO2 and H2O. And that's balanced already, isn't it? And just a quick reminder, so we said it's very similar reaction between the metal oxide and acid, and it's also very similar to when you add a metal hydroxide and acid, because you get a salt and water. Okay, just a short one, we'll leave that there.